5.4 Graphing functions using function tables. When we use function tables, we are giving our domain and we're finding our range with them. So if we look at example 1, it tells us to graph the function x plus 3y is equal to 15. From there, you want to solve for y, because you're solving for y when you get these ordered pairs. They give you the domain of 0, 3, 6, and 9. So you want to plug in the 0, find for y. You want to plug in the 3 for x, find for y, and so on. So we're first going to start by taking that x plus 3y is equal to 15 and solving for y. So we're going to move the x over by subtracting it. We get 3y is equal to negative x plus 15. And then we're going to divide each side by 3 to get y is equal to 1/3, negative 1/3 x plus 5. So this is what we're going to be using in our function table for our function rule. So we have x values, which are our domain, which we said is 0, 3, 6, and 9. We then have our function rule, which is y is equal to negative 1/3 x plus 5. And then we are going to solve for y. So we're going to plug in the 0 first. We're going to have negative 1/3 times 0 plus 5, which is equal to 5. Then we have the negative 1/3 times 3 plus 5. Negative 1/3 times 3 is negative 1. Negative 1 plus 5 is going to give us 4. And then we have negative 1/3 times 6 plus 5. So negative 1/3 times 6 is negative 2. Negative 2 plus 5 is 3. And then we plug in the 9. Negative 1/3 times 9 plus 5. Negative 1/3 times 9 is negative 3. Negative 3 plus 5 is 2. So these are the ordered pairs of 0, 5, 3, 4, 6, 3, and 9, 2. So when we go to plot these on our coordinate plane, the 0, 5 is going to be here. Then we have 3, 4, so right 3 up 4. That's going to be here. And then we have 6, 3, which is here. And then 9, 2, which is here. If we look at our next example 2, we have to graph y is equal to x squared. So we are finding our own domain here. So I like to start with negative 2, negative 1, 0, 1, and positive 2. So I'm going to do my function table of x, and then we have y is equal to x squared. And then we have our y. My x values I'm going to use are negative 2, negative 1, 0, 1, and 2. From here, we're going to plug them in to that x squared. So we're going to have negative 2 squared, which is 4. Then we have negative 1 squared, which is 1. Then we have 0 squared, which is 0. Then we have 1 squared, which is 1, and 2 squared, which is 4. So these ordered pairs that we have are going to be negative 2, 4, negative 1, 1, 0, 0, 1, 1, and positive 2, 4. Oops. All right. So if we go to plot these points, we're going to have negative 2, 4. So to the left 2, up 4. It's going to be here. Negative 1, 1, 0, 0, 1, 1, and positive 2, 4. So from these points, we can actually draw a line through them, making sure those arrows are top and bottom of that line, or in this case, both top of that line. If we look at our next example, we have f of x is equal to 3x minus 5. Remember, f of x and y are the same thing. So we're going to have x, we have 3x minus 5, and we have f of x. So we are going to pick our own x values here. So again, I'm going to do -2, -1, 0, 1, and 2. I'm going to plug these in and solve. So we're going to have 3 times -2 minus 5, 3 times -1 minus 5, 3 times 0 minus 5, 3 times +1 minus 5, and 3 times 2 minus 5. So 3 times -2 is -6. -6 minus 5 is -11. 3 times -1 is -3. Minus 5 is -8. 3 times 0 is 0. Minus 5 is -5. 3 times 1 is 3. Minus 5 is -2. And 3 times 2 is 6. Minus 5 is 1. So we are given the ordered pairs here from these as -2, -11, -1, -8, 0, -5, 1, -2, and 2, 1. So when we graph these, we are going to have -2, -11, which is here. Then we have -1, -8, which is here. 0, -5, 1, -2, and 2, 1. So we can actually draw our line through these ordered pairs. And then we're done. If we look at example 4, we have -x squared. So again, we're going to do x, we're going to do y is equal to -x squared, and then we're going to solve for y. So I'm going to use -2, -1, 0, 1, and 2. So this is just going to be negative times -2 squared. Negative times -1 squared. Negative times 0 squared. Negative times 1 squared. And negative times 2 squared. So this is going to give me -4, -1, 0, -1, and -4. So again, I have ordered pairs of -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. So plotting these, -2, -4 is here, -1, -1 is here, 0, 0, 1, 1, and 2, -4. So then I draw my line through those points, make my arrows, and then we're done. If we look at example 5, we have y is equal to -4x plus 2. So we are going to do our same thing that we've been doing. Draw your function table. We have x, we have y is equal to -4x plus 2, and we are solving for y. So I'm going to have -2, -1, 0, 1, and 2. And plug these in. So this is going to give me -4 times -2 plus 2. That's going to be 8 plus 2 is 10. Then we have -4 times -1 plus 2. So 4 plus 2 is 6. -4 times 0 plus 2. 0 plus 2 is 2. -4 times 1 plus 2. -4 times 1 is -4. -4 plus 2 is -2. And then -4 times 2 plus 2. It's going to give us -8 plus 2, which is -6. So these ordered pairs that we have are -2, 10, -1, 6, 0, 2, 1, -2, and 2, -6. So we plot our points here. -2, 10, -2, 10 is here. Then we have -1, 6, which is here. 0, 2, which is there. And then 1, -2, and 2, -6. So we can then draw our line through these points, trying to make it as perfect as possible. Sometimes if you have your ID, that's perfectly fine. And then we're done. If we look at our next set of examples, we're using a graph to find the value of f of x when x is negative 2 for each function. So we are graphing it and then figuring out where our y value is when x is negative 2. So if you want to use a function table, you can. If you want to just find your x and your y-intercept, you can. It's totally up to you. I'd rather find my x and y-intercept. If I do that, my x-intercept, my y is going to be 0. So this is going to be 0 is equal to negative 1/2 x plus 3. Move that 3 over. And I have negative 3 is equal to negative 1/2 x. Multiply each side by the reciprocal of negative 1/2, which is negative 2 over 1, or negative 2. And x is going to equal 6. So this is the ordered pair 6, 0. For the y-intercept, we are going to plug in 0 for x. And we're going to have y is equal to negative 1/2 times 0 plus 3. So this is going to be y is equal to 0 plus 3, which is just y is equal to 3. So that's the ordered pair 0, 3. So once again, I'm going to plot these 2 points. 6, 0, 0, 3. 0, 3 is here. 6, 0 is here. So when I graph this line, I can also find where my y, or what my y is when x is equal to negative 2. With this, I can't draw a straight line, so it's not going to work out when I do this. So I'm going to actually plug in negative 2 for my x and solve. So we're going to have y is equal to negative 1/2 times negative 2 plus 3. Negative 2 times negative 1/2 is 1, plus 3 is 4. So y is going to equal 4. And then this is going to give us the ordered pair of negative 2, 4. If we look at B, we have f of x is equal to 3 over 2x minus 4. So again, we can find my x and my y-intercept, plot the line, and then pull from the line what my y is when x is negative 2. Or what I'm going to do here, since we cannot draw a straight line on this, we're going to have 3 over 2 times negative 2 minus 4. 3 over 2 times negative 2 is going to give us negative 1. Negative 1 times 3, which is negative 3 minus 4. And this is going to give us negative 7. Y is equal to negative 7. So this is our answer. And then if we were to plot it, it would just be negative 2, negative 7, which is here. And then if we found our x-intercepted, it would be negative 4. Our y-intercepted is negative 4. So we do have 2 lines from here. We can just, or 2 points, we can draw our line through those 2 points. So for our next one, we have that x is 3 and we're finding for y. So x is 3, we're going to have negative x plus 7. So this is going to be f of 3 is equal to negative 3 plus 7. Negative 3 plus 7 is 4. So our y is going to equal 4 here. So again, we can find our y-intercept by that 7. So we'd have 1 point at 0, 7, and then we have that other one at 3, 4, 3, 4, which is here. So 2 lines, or 2 ordered pairs. We can draw our line through them, and then we're done. And then that y is equal to 4 when x is 3. For our next example, it tells us that the Mid-Atlantic Ridge separates the North and South American plains from the Eurasian and African plains. The function y is equal to 2.5x relates the number of centimeters y in the mid-Atlantic ridge separates after x years. Graph the function and use the graph to estimate when or how many centimeters the mid-Atlantic ridge spreads in 4.5 years. So if we find our x-intercept and our y-intercept and we plot those points and then draw the line, we can do that. Or we can say that y is equal to 2.5x. Our x is going to be 4.5, so we're going to plug that in. So we're going to have 2.5 times 4.5, which gives us 11. And then again, we would graph that line, finding the x and the y-intercept, and then using the whenever y or x is 4.5, we find that y is 11. For example 8, we have that a cruise ship is currently 5 kilometers away from its port and is traveling away from the port at 15 kilometers per hour. The function y is equal to 15x plus 5 relates the number of kilometers y to that the ship will be from the port x hours from now. Graph the function and use the graph to determine how far the cruise ship will be from its port in 2.5 hours from now. So we're going to use y is equal to 15x plus 5. We're going to say that x is 2.5. And we're going to plug this in. So we're going to have y is equal to 15 times 2.5 plus 5. The 15 times the 2.5 is 37.5. And if we add 5 to that, we're getting 42.5. So y is equal to 42.5. And then again, for this one, we would find the x and the y-intercepts, plot the points, and then draw the line and get what our answer is.